Okay, so here we are at part E. So this time we have all of the logarithmic expressions have the same base. They're the common log, so they're base 10. But this time we have to simplify on the left side, and then we have to simplify again on the right side. So here we have a subtraction, so that means we're going to use the quotient property. So we get log base 10 of x plus 6 over 10 is equal to, again, on this side, we also have subtraction, so we're using the quotient property again. So we have log of x minus 1 over 2. So here we have logarithm to the same base on both sides. That's the only thing that's occurring on both sides. There's no extra constants or anything. So we are going to set the two arguments equal to each other. Okay, I have two rational expressions set equal to each other, so I cross multiply. 2 times x plus 6, okay, I'm multiplying that way, is equal to 10 times x minus 1. Using the distributive property, I get 2x plus 12 equals 10x minus 10. I always move my x's to the left, my constants to the right. 2x minus 10x is going to give me negative 8x. I'm going to have to subtract 12x from both sides. And I get negative 22. I divide by negative 8 on both sides. And I get x equals, 2 goes into both of these, 11 fourths. Oh, I'm sorry. I needed to go down a little bit. Okay, and I am going to look and notice that when I try to plug this back in, I would much rather be dealing with a clean decimal than a fraction. So I am going to convert my 11 fourths. 4 goes into 11 two times with 3 fourths left over, which is 0.75. Okay, so since these are exactly equal, you can use either of them. So now I am just plugging into my original equation. So I have log, it was x plus 6, so 2.75 plus 6 is going to be 8.75 minus log of 10. And I want to see if that is equal to log of 2.75 minus 1 is going to be 1.75 minus the log of 2. Okay, I'm sorry, my screen is not showing this great right now. I substituted x into my original equation and got these values down here. So now I am going to my calculator. So I want to see if log, which is nice because I have the log button, I want to see if log of 8.75 minus log of 10, if that is equal to, if the left-hand side is equal to the right-hand side. So log of 1.75 minus the log of 2. Okay, and since I do get the same answer, that means both sides are equal. Okay, this is not something that you can do in your head. Okay, you could use the quotient property and see that this would be equal to log of 8.75 divided by 10 would be 0.875. And 1.75 divided by 2 is also 0.875. Okay, so you could see by hand that they were equal like that, but I think a lot of us are much more comfortable with the calculator.